Hello students, this is the world of chemistry. I'm Dr. Vikram Panchal and this is the second lecture about chemical kinetics. Okay, this is lecture number 2. In previous lecture I was referring about reactions, chemistry, physical reaction and chemical reactions. And we referred also about the thermodynamics and its importance. But basic drawback of thermodynamics is that it cannot explain that how much time required to complete reaction. So that is called rate of reaction. So in this lecture, we will study what is rate of reaction. Well, chemistry is most fascinating subject and all reactions are very funny. Some reactions require millions of years and some reactions require fraction of a second. Depends. For example, making of petroleum. You know, petroleum is always available under the earth. So how it formed? You know that. Millions of years ago, the fossils and natural due to natural calamities, all living beings were buried out, and in that case they were decomposed during the time period, and then they all were converted into petroleum. So it required millions of years. So making of petroleum require millions of years. But you know that you can't smoke at petrol pump. Why? Because at gas pump, vaporization of petrol or diesel is continuously happening. And if you smoke over there, one small spark is enough to catch fire. So burning of petroleum requires fraction of a second. So this is the most funny part of this chemistry, that some reactions require very small, less time, and some reactions require a lot of time. Okay, and that is why rate of reaction is very important, because rate is related to time, that how much time required to complete the reaction. So that information is available from chemical kinetics. So let us start with rate of reaction. So when we write any chemical reaction, first of all we write reactants. So in this reaction, whatever is written on the left hand side is called reactant or reactants. Okay, then we put arrow. If we put arrow on both the sides, that means it is called reversible reaction. Okay, and right side is always product. So reactant is always converted into product. So if we consider initial condition, that at initial concentration of reactant is always maximum, because we start with reactant, so reactant should be maximum in the beginning. Okay, what will be the amount of product in the beginning? Nothing. Don't say minimum, it is 0, so we don't write anything in the right hand side, initial concentration. Now when the reaction starts, the reactant is converted into product. So during reaction, what happened? Reactants are changing, and therefore concentration of reactant decreases and concentration of product increases, because product starts forming, and that is why concentration of product increases. When the reaction is over, that is final concentration. So final concentration of reactant would be, don't say 0, because you cannot have 0 concentration of any reactant left at the end of reaction. So it is always minimum, and products will be maximum. Okay, that means none of the reaction gives you 100% product. Why? Because it is reversible. So if you get 100% product, part of that will be again converted into reactants. So depends on the conditions, we will get amount of product. Okay, but it is maximum with respect to initial state, and concentration of reactant is minimum with respect to initial state. Okay, now we can represent the whole thing in the form of graph, because chemistry also deals with graphs, and that's why you should know how to read graph. Okay, so let us see what happens during the reaction with graph. Okay, so on y-axis or y coordinates, let us take concentrations, and on x-axis we can take time. Okay, so with respect to time, concentration of reactant at 0 time will be maximum. So this is the concentration of reactant which is maximum, and concentration of product will be minimum. You know, box bracket indicate concentration. That is why I write R means concentration of reactant and box bracket P means concentration of product. So at 0 time, concentration of reactant is maximum, concentration of product is minimum. Now with respect to time, what happened to concentration of reactants? With respect to time, reactant will be decreasing. So concentration of reactant goes on decreasing, okay, and concentration of product goes on increasing like this, okay. At particular time, concentration of product will be maximum but constant, and concentration of reactant will be minimum but constant. Now there is no change in conversion, or there is no conversion. That means the time required to complete the reaction is this much. Okay, so this is the time required to complete the reaction. Okay, so this way we can find out how much time required to complete the reaction. But remember, with respect to time, concentration of reactant always decreases, concentration of product always increases. Okay, now we can put this in terms of relations with time and concentration, and that is called rate of reaction. So rate of reaction is equal to decrease in concentration of reactant and upon time. Remember, rate is always related to time. So decrease in concentration of reactant upon time, or we can write increase in concentration of product upon time. So either you can take reactant or product with respect to time, and that is called rate of reaction. Now the most important part of this reversible reaction is equilibrium state, and you know what is equilibrium. So equilibrium is very important state of any chemical reaction. So at equilibrium state, the rate of forward reaction, that means conversion of reactant to product. So the rate of forward reaction, for that we write VF, is always equals to rate of reverse reaction. Okay, so rate of forward reaction is always equals to rate of reverse reaction at equilibrium state. Means whenever there is equilibrium, matlab end of the reaction, at that time rate of forward and rate of reverse will be equal. So now there will be no change in concentration of reactant or concentration of product. So at equilibrium, Remember that concentration of reactant, all reactants, is always minimum and constant. So there will be no further change. Similarly, concentration of product is always maximum and constant at equilibrium. Okay? So further change is not possible when the reaction is reversible and at equilibrium state. At equilibrium also, you will find that temperature of the system is constant. There is no change in temperature. If reactants or products are in gaseous state, then we can say pressure is also constant. So pressure of the system is also constant. That means all external factors are constant. Concentration, temperature, and pressure all are external factors and they will remain constant during equilibrium state. Remember, for equilibrium there should be reversible reaction. Second condition, the rate of reverse reaction is always equals to rate of forward reaction or vice versa. And concentration of reactants constant, minimum, concentration of product constant, maximum. Temperature and pressure will be constant. So this is regarding rate of reaction for chemical kinetics. Okay. Thank you so much.